Well, welcome everyone. Welcome to this event on food systems and climate change, hosted by the Food Climate Partnership and Columbia University's Climate School. My name is David Sandalo. I'm the inaugural fellow at the Center on Global Energy Policy at Columbia University and a co-founder of the Food Climate Partnership. This is a big week for political attention on climate change and food systems here in New York. Yesterday, the Secretary General of the United Nations hosted heads of state to talk about the climate change issue. And actually last Friday in Washington, DC, President Biden did the same thing. On Thursday, the UN Secretary General is convening a food systems summit as part of the Decade of Action to achieve the Sustainable Development Goals. The summit on Thursday is going to launch actions to deliver progress on all 17 of the Sustainable Development Goals, each of which rely in some fashion on the food system. And one of the goals of the Food System Summit is to raise awareness and elevate public discussion on food systems. And as part of that effort, we're holding this discussion today with a really extraordinary group of experts. And I'm thrilled to introduce my friend and colleague, one of them, Cynthia Rosenzweig, to help welcome us. Cynthia is well known to many people in this community, but she's a senior research scientist at NASA Goddard Space Institute and a co-founder of the Agricultural Model Intercomparison and Improvement Project, AgMIP, and a real leader on food system issues. And along with me, a co-founder of the Food Climate Partnership. So Cynthia, welcome.
Thank you, David, and welcome to everybody on this Climate Week event. Thanks for joining. I wanted to just tell a bit more about the Food Climate Partnership, which is a new initiative, although maybe we're now over a year old, so maybe we can't say we're new kids on the block anymore. But it's led by members of AgMIP, Columbia University, and SIPA, the School for International and Public Affairs at Columbia University, New York University, and FAO. And what the Food Climate Partnership brings together scientists who work on the technical aspects of climate change, the processes, what's going on, for example, with greenhouse gas emissions. You're going to hear more about that in the program. But at the same time, the work is done side by side with policy experts, because what we've come to realize is that we can't be waiting for the scientists to be doing their work and throwing it over the fence, and then later on the policy experts take it up and go forward. The challenges of responding to climate change are now so great that we really need to do what we call the double helix of science and policy work together. And that's really what the goal of this event is to share with all of you some of the initial work, the background work of that the FCP has been doing, and linking this also to in both science and policy, and also linking to the new initiative at Columbia University, the Climate School, the very, very exciting Climate School, which is the co-sponsor of this event. So with that, David, back to you to introduce the Senator Gillibrand's remarks and also our panel. Thank you.
Thank you so much, Cynthia. And just a few program notes. First, this is being recorded, and we will post the video on the website of the Food Climate Partnership, which is foodclimatepartnership.org. That's foodclimatepartnership.org. If you have any questions, please put them in the Q&A. I expect a lot of people are familiar with this now, but please post them, and we will be looking at questions coming in after the presentations. And now I'm really delighted to introduce Senator Kirsten Gillibrand, who has honored us with a video welcome for this event. I think anyone, certainly in New York and around the country, knows Senator Kirsten Gillibrand well. She's senator from the state of New York since 2009. She serves on the Agriculture Committee and has been a powerful voice both on agriculture issues and on climate issues, and has paid attention to the work that we're doing, and we're delighted that she's able to introduce this event. So with that, Senator Gillibrand.
Hello, I'm Senator Kirsten Gillibrand, and I'm delighted to welcome everyone participating in today's event with Columbia University and the Food Climate Partnership as part of the Climate Week New York City 2021. This summer, the climate crisis went from theoretical to terrifyingly real for many around the world and the country. We watched as families battled wildfires, floods, droughts, and landslides. And then Hurricane Ida arrived at our doorstep here in New York. I've seen the devastation with my own eyes, and it reinforced what we all already know. It is far past time to address the challenges of climate change and accelerate climate action. I'm grateful that today's event centers around the intersection of climate change and our food systems. As a member of the U.S. Senate Committee on Agriculture, Nutrition, and Forestry, this is an area I care deeply about. I look forward to learning about the policy recommendations generated today and working with all of you as we tackle the essential work ahead. Thank you for your participation in today's event. You have my best wishes for a fruitful and inspiring discussion.
Well, thank you, Senator, and thank you for your work on these issues. And now I'm delighted to introduce our first speaker today, Walter Baitkin, who is a senior research scientist at Columbia University. Walter is director of the Regional and Sectoral Research Program at the International Research Institute for Climate and Society. He's established regional programs that aim to improve climate risk assessment and risk management in agriculture, health, water resources, and natural ecosystems. And last year, he became vice president of the board of directors of the Uruguayan National Agricultural Research Institute. Walter, welcome, and we look forward to your presentation and the conversation afterwards.
Thank you, David, and welcome everybody. I'm going to share my screen, so that's sure. Please let me know when you see it.
Yes.
Okay, great. So this is basically what I will try to discuss in a very few minutes, and hopefully we'll have a chance to discuss more in the questions and answers section. But basically is how can these two communities, policymakers and researchers, work together in the food system community to make more effective and to address more effectively the climate crisis. And this is the situation today. We all know we have climate change affecting the food systems in different components, in the production, in the transportation, in the storage. But then we also know that the food system is one of the main emitters of greenhouse gases, so it's also affecting climate change. Now, in spite of knowing that, this is the way that we are working today. We have a science agenda, we have a policy agenda, we have institutional arrangements, international initiatives addressing climate change, and then separate science agenda, separate policies, etc., addressing the food system. And this is why what we're trying to change. This is one of the objectives of this event, is trying to change the situation. Now, what is happening in the research in the academia sector? The reality is that in research and academia, we promote working in silos. That's the way our system is organized. How do we measure our success? Is how many articles we publish in specialized journals. And the more specialized the journals are, the better. How are we promoted? You know, we are evaluated by peers who work in the same areas as we do. And this, of course, discourages transdisciplinary approach, a systems approach. And of course, when we go out and try to help inform decisions and policy, of course, we realize that world challenges are not organized according to our academic disciplines. And in fact, we find this very clear gap. Even scientists that are really trying hard to inform decisions, to inform policy, find a lot of difficulty. And I think one of the challenges is just the way that we work. How a decision maker, a policy maker, they approach problems holistically. They don't look at one dimension of a problem. They look at the whole situation, and also very often intuitively. And how do we work in the scientific community? Exactly the opposite. we're becoming better and better, more and more knowledgeable about smaller and smaller things. And so we create these islands of knowledge in an ocean of ignorance. So we know a lot about some very specific, well-defined topics, but we don't connect those topics. And policymakers, they don't go hopping from island to island. Decision makers, policymakers navigate that ocean. So this is what we need to do. This is what we need to change. We need new approaches. We need new tools to integrate this wonderful knowledge that is being generated in academia and in research institutions. And very importantly, we need to promote the creation of integrators, people, researchers that are able to integrate this wonderful knowledge and translate it into something that is understandable and actionable for the policy community. Now, I'm not going to even dare to explain how policy and institutional arrangements work, but I'll just tell you very briefly what is my own experience in Latin America. This is the way that policy and institutional arrangements are in most Latin American countries. We have Ministry for the Environment, a Ministry for Agriculture, a Ministry for Public Health, a Ministry for Science and Technology, and of course, reigning about all, the Ministry of Finance. Now, these ministries are competing among each other. They're competing for resources, they're competing for relevance, they're competing sometimes for political power. And so then when you introduce a subject like climate change or food systems, how is this treated in the policy environment, in the institutions? Well, climate change, there's some aspects of science that is the business of the Ministry of Science and Technology. There's some aspects that is being treated by the Ministry of Agriculture. When they go to the COPs, the Ministry of the Environment represents the country, and the food system, same thing. Some of the aspects may be in production, maybe in Ministry of Agriculture, some in public health. So the reality is that the problem that we see in the scientific community, we see something similar in the policy community too. The reality is that we all work in silos. It's very comfortable to work in silos. In the academic institutions, again, we promote to work in disciplines. We call success when we publish in very specialized publication. And of course, we discourage integration, the systems approach. And in the policy institutions, institutions are arranged by sector. And those institutions compete for resources, for relevance, for political power. And also often it discourages coordination. So what we need is really a cultural change. We need a deep change in the way that we are working. Now, the nice thing, the good thing, the good news is that changes are already happening. During this week, David was mentioning, there was a lot of activities happening in New York. But before that, what is happening in Colombia? This is something that I know well. So the president of the university 4 or 5 years ago, he said, you know what, Colombia has been a wonderful university for the 3 typical classical purposes of any university. We have been doing a very good job educating people, conducting very good research, and providing services to the community. But let's work on a 4th purpose. Let's try to go out and try to help solve world challenges, world problems. And the result of that, the first result, was the creation of a wonderful program called Columbia World Project. And that was the idea. The idea is to take advantage of all this wonderful knowledge being created in the university and connect to the actual institutions where policies are made, where laws are made, where the actions are taken. So connect to these communities effectively. The first Columbia World Project is called Act Today, which means adapting agriculture to climate today for tomorrow. So basically it's asking the question, what can we do today to improve the resilience, to improve the adaptive capacities of societies, and improve the food security situation? How can we contribute to the Sustainable Development Goal number 2? And then after that, as part of this evolution, the university created a new school. And this is a big thing. This is a big thing in universities. I think the last time that Columbia created a school was 30 years ago. Now we created a new school, which is the Columbia Climate School, that David and Cynthia also mentioned. And this is wonderful. This is giving the structure to do this, to conduct this transdisciplinary work, what is needed. We want to inform decisions. We want to tackle world challenges. We know that we have to go outside of our silos, outside of our comfort zone. And the climate school is a wonderful structure for that. And part of the climate school is the creation of networks. So now Cynthia and I are part of this network for healthy and sustainable food systems, where we have people that come from climate science, from agricultural science, from political science, from economics, sustainable investment, a lot of very heterogeneous community working under the objective of envisioning healthy and sustainable food systems. And also look what is happening this week in New York. In this week in New York, yes, we have the UN General Assembly, but we have a Climate Week and we have the Food System Summit, and we have a lot of activities trying to connect those two things. So for example, there was a special activity, a special event for September 14th, and this is what they're trying to do, is explicitly bring together the UN Food System Summit with the COP26. So we're saying, let's bring these agendas together. There were several activities like this, and of course, this is what we're doing today. What we're doing today is discussing how we can bring these communities, the scientific community, the policy community, under the lens of food. So just to wrap up, in research and academia, we really need a revolution. We need a new culture. The problems of the world are not organized to academic disciplines, and if we really want to inform decisions, policies, we need to start integrating that information, integrating that knowledge. That means creating structures that promote the transdisciplinary work. And that means that part of that revolution is we need to create new career paths. We have to be innovative here. We have to promote not being evaluated by our own peers who work exactly in the same areas as we do. We cannot measure impact just by counting the publications that we have in high impact factor journals. And we need to start promoting these integrators. These researchers are able to understand to different disciplines, to integrate that knowledge and translate it into something that is actionable for policy. And in the policy agenda, of course, I'm not going to even dare that I know what to do in policy. But one thing that I can say is, what have we learned with this COVID, with the pandemic crisis? One of the things that we learned is that countries that were more successful were countries where the scientific community was able to create cross-cutting science and created mechanisms to inform policies. We have wonderful examples in the world. And the other thing that happened in the countries that were successful, they were able to coordinate better between institutions, public health, economic, forced labor. And so my optimistic finishing message is, I truly believe, we believe, this is why we're organizing this event, that we now learned enough about how to do things to establish this cross-cutting agenda between policy and food and climate change. Thank you.
Walter, thank you so much for those very thoughtful remarks. A very important topic, and I say it's very true to my experience. My background is actually much more in the policy world than in academia. I've only come to academia relatively recently, and I can testify that very often when the two communities talk, they miss each other. They're often talking in different planes, and academics will talk with too many qualifiers over too long of a term and too long-winded in ways for policymakers to relate to. And policymakers can frustrate academics because they want the answer right away and they're moving on to the next issue and more. So I look forward to coming back to this in the conversation. Welcome any questions from anybody in the audience on these topics. And let me then turn to our next speaker. I'm delighted to introduce my friend Francesco Tubiella, who's a senior statistician and team leader for environmental statistics at the Food and Agriculture Organization in Rome. Francesco focuses on assessing the linkages between agriculture, food security, and climate change. He leads data collection, analysis, and dissemination of several of the FAUSTAT data domains, including land use, fertilizers, pesticides, greenhouse gas emissions, and more. He's a leading expert on these topics. We're thrilled you're with us today. And Francesco, the floor is yours.
Thank you, David. Welcome to all the participants, and thank you for the time you're dedicating to us wherever you are in the world. And thank you for inviting me, even though virtually, to New York. And I'll try to connect the dots with hopefully interesting arguments from across the ocean. Let me share my screen, and please let me know when it works and you see it.
Perfect. There it is. Yeah, it's
excellent.
It's not. Yep, there it is. Perfect.
Okay, so thanks, Walter, for your great presentation. I'm going to try to connect some dots, minor dots in the sea of challenges that we have exactly between science and policy. I mean, I've actually been at Columbia University for many years in the research arena and moved over time, to several experiences in climate change processes, which landed me at FAO, where, of course, the kind of work that we do, FAO is a technical agency of the United Nations. So we do a lot of research, but the ultimate goal is generating knowledge to support policy and governance in our member countries. And you will see where this is going in terms of the work that we're doing on greenhouse gas emissions. So let me start with a few considerations, which I think are relevant to set the tone of what we are interested in. This is something that I always like to say in all my presentations, but if you think about it, food and agriculture have shaped human culture and civilizations from the beginning. We're talking 10,000 years for agriculture and a few million years for food. And now affect the planet at all scales, including planetary. And we know what that means both in terms of emissions and impacts from climate change to agriculture. Just think about that the very word culture comes from the cultivation of soil. And it's really what got us all started on this mission to explore and understand our world and making it a better place. Now, in terms of that impact at all scales, including global, we know that the emissions from these food systems are very large. And we've seen several papers this year, including some produced by the partnership, which are pointing, and previous work led by Cynthia, in fact, on IPCC a couple of years ago, that point to the fact that food systems emit about 1/3 of the total anthropogenic emissions in the atmosphere. Now, that is, of course, big in terms of systems. It's perhaps, together with the energy systems, the largest negative contributor to the health of our planet. And now the question then is, starting from this point and recognizing that there is a policy, a climate policy path where countries are committing themselves to trying to do something about it. In other words, we've heard about adaptation, but the ultimate cure here is, of course, at the same time trying to reduce the emissions and therefore mitigation. How can countries better characterize their food systems? And of course, note that food systems, I use it in a plural because there are many representations of food systems with many different characteristics around the world. How can they better characterize them to help them address the commitments that they're making under the Paris agreements, for example? There are, of course, many recipes and important things to do, but I'll highlight two here that link directly to the work that we're doing within the Food Climate Partnership NFAO. One is, of course, to improve the data that we have, right? That includes research, and that's the science part. And why do we need better data? We already know, of course, that emissions are roughly 1/3 of the total. But we need to collect information on, which emissions, by which gas, by which process, by country, and what is their trend over time, so that we can properly identify trends, and which help us basically hone into which are the effective actions around the world today that can be implemented over the next 10 to 20 years. We don't have more time than that. And the second is this linkage. Many of you may be familiar with the UNFCCC, the Climate Convention process, where countries report. It's a major international reporting process, report their data on climate change and in particular emissions at regular intervals, increasingly almost at annual intervals. But they use a climate policy jargon, and allow me to use this term, and I just mean it in a very constructive way. But we need to translate that jargon into something that speaks directly about food and agriculture in a way that those concepts can be readily understood by farmers, consumers, which can then communicate better to their politicians for real action. And this is at the moment a stumbling block, which many are trying to address around the world. And I just note here, although I don't have it in my slides, that we have what we call a stock-taking exercise, starting, in fact, later next year and going full force in 2023, where countries will sort of get together with scientists to try to assess where they are in their fight to climate change. And so translating the climate policy jargon that's used in reporting with the science is fundamental so that people can understand each other. Now, let's start from a perspective of food and agriculture in terms of what is important to, as I say, people on the farm and consumers alike that can sort of recognize these terms. But as the literature in which also we've been involved has developed over the last few years, we're sort of characterizing now food systems, which of course encompass everything under the sun that relates to food, from production on the farm to manufacturing of food, to transport, and all the processes that also Walter has alluded to. For simplicity, we tend to divide them up in three components. The farm gate, so everything that happens on the farm, crops and livestock production, for example, but also energy use on the farm. The land use change component, this is all those processes that bring new land for cultivation with, at the expense of natural ecosystems, and you can relate probably very, very much on, with the concepts of deforestation, degradation of peatlands, forest fires, and so on. These are largely linked to agricultural practices, not all, but in large part. And then, of course, we have processes beyond the farm gate. We call them pre and post-production processes, and include all those activities that are needed to bring food from the farm, or at least once it leaves the farm gate, to the consumers through manufacturing, through processing, including consumption processes at home, and then waste disposal. Okay, so these are more or less the three components that we know how to deal with in terms of basic understanding of what they are and what role they play in our society. Now, just to put things in perspective, and sort of it's not a spoiler because you'll see a lot more data later on, but the basic construct that we start with, and that sort of justifies the attention on food systems, as I said, that the grand total of the greenhouse gas emission shares of these three components into the total emissions is about 1/3. And more or less within the uncertainty of the data, you can think of all those three components as an equal contributor to those emissions. This is in itself is knowledge that is relatively new. We've always put our attention to what happens on the farm in terms of non-CO2 emission gases, on important processes, of course, as the destruction of ecosystems. And we never quite got around until very recently to quantifying, especially the fossil fuel-based CO2 emissions that happen, after the food leaves the farm. So that's a major, let's say, concept that we use as a starting point in this travel towards linking this to policy and effective action. So what is instead the climate policy work? How does it look like? So here on your left, you have these categories, which people that compile, so-called the national greenhouse gas inventories, which are the instrument with which countries report their emissions every year to the convention, are, right? So you have agriculture, you have LULUCF, which for those of you who haven't not yet run into it, means land use change, and forestry, basically all the land processes outside, in part inside, but mostly outside of the farm at the boundary with ecosystems. And then, of course, all the activities that are linked to energy production and consumption, industry, manufacturing, and waste disposal. Okay, so these are sort of the two silos, if you will, the two set of silos, conceptually speaking, that in a sense stand between, a productive discussion between those who research, from a science-based these issues, and those that report the information to the convention. So what do you need here? And this is part of the work that we've engaged in together with colleagues here on the panel, through the partnership and FAO, of course, trying to build, if you will, a Rosetta Stone, translating the policy jargon into the food and agriculture language. And this is not meant for you to go into every single detail of what's in there, but you recognize on the left of the table the IPCC world. IPCC stands for Intergovernmental Panel on Climate Change. And on the left, language that is more familiar to people like me and my colleagues that work directly on food and agricultural issues. So what happens with this Rosetta Stone? In a sense, you're able to connect how countries report their emissions in those siloed components into something that's relevant to food. And in return, you can then use the information to compute country by country within a database, all the various important trends, but by country in terms of what is the weight of farm gate, land use change, pre and post production into those emissions. I say this at the end, but before it gets out of focus, I mean, this link in policy. So on the one hand, countries report on their national greenhouse gas inventory, but the main policy document that is on everybody's mind when we talk about Paris Agreement and commitments is the so-called NDCs, right? The National Determined Contributions. Now, those national determined contributions are written in the policy jargon. So a country that would like to sort of characterize or break apart that information into something that's relevant to its own food system wouldn't be able to do it until this sort of translation is put in place. So very, well, throughout this year and before, we've been engaged in a lot of efforts with colleagues from FAO and Columbia universities in putting this information into an extension of our FAOSTAT data sets. And what we have, and hoping it's already prepared and it's being peer reviewed, and we hope to have it ready for the COP, is what we call an emission share database, which covers emissions across the entire food system path for all the relevant gases for all the countries in the world and territories, and over a long time series. So it allows to do exactly, it responds to that call that I posed in the beginning, providing data with the right granularity to at least begin addressing the peculiarities of the food systems in terms of emission and identify hotspots for action. So I'll just spend the rest of the presentation. I only have a few slides to provide you with an idea of how those results look like and what they say in terms of importance to action globally, but also by country. So first of all, and you're welcome, and I invite you for sure to peruse the database once it's out. There are many visualization possibilities there, but in terms of a global view, what you can see is a picture of what, how those emissions evolved over time. Here you see the time series from 1990 to 2019. By the way, there's no database in the world that is providing the user with information updated to 2019, and we're hoping by December to have an update to 2020, which will include statistics that describe the impacts of COVID. But what you see here basically is a couple of things. One is near equal contribution today of the three components of farm gate in yellow and the land use change in green and the pre and post production in blue, with a decrease over time of the land use change component. And that's simply due, of course, to a reduction in the weight of deforestation in total emissions in the world. And in a sense, although this remains a fundamental problem that we still need to address in its entirety, it's a reflection of how a tradition, an agricultural system evolves in this collectively, of course, from traditional to modern agriculture. And increasingly, and relatively speaking, a higher weight over time of the pre and post-production processes. Those are the CO2 emissions, which we didn't tend to think were so important when we spoke about agriculture, but they are once you consider the larger picture of food systems. Of course, the database is very detailed, so you can produce things like a Sankey diagram that marries, in a sense, the IPCC world to the left, and how those emissions, this is a global picture, would then reverberate and propagate into a food system perspective. You can also quantify things that we usually don't discuss when we talk about the weight of emissions in total anthropogenic emissions. We tend to think in terms of CO2 equivalent. That's the last column there. But you see that if you look at the problem in terms of emissions in the single gases, these are the three most important: CO2, methane, CH4, and nitrous oxide, and 2O. The picture is even more, highlights even more the importance of food systems in the global picture. And you see that whereas, when you collect all the information, you have a weight of about a third to that total. If you look at N2O, that's actually 80% of the emissions coming from food systems, in particular, in this case, from the farm gate, more than 50% for methane, and about a quarter of CO2. So this helps you characterize, where it might be important to act. This is, of course, a global picture, but keep in mind that the database provides this sort of picture by country. And also helps characterize, how developed versus developing world countries look like. And here, just to give you a bird's eye view of things that, of course, have now been consolidated in the literature, but providing that view and that picture between so-called modern intensive systems in Annex 1 countries, meaning OECD type developed countries, where, of course, the emissions from agriculture within the farm are small and becoming smaller than even the pre and post production component, as opposed to what happens in countries that are still moving from traditional to land or capital intensive systems all the way to modern agriculture, where, of course, the land use change component is still dominating. And finally, just to highlight some of the uses that such a wealth of information can be put to, is you can look at individual countries. Of course, what we like to do as statisticians is do top lists, but at the bottom line here, and the main concept is that you can follow what happens in each country and characterize how the makeup of the food system is, so you know where to act. So you go from a country, like China, where basically you have no impact of land use change on total emissions, but a significant component, both on the farmer pre and post, to countries where we know there is still a significant ongoing destruction of ecosystems for a variety of reasons and linked to a variety of agricultural practices, whether it's Brazil for deforestation or Indonesia, where it's mostly peatland fires and peatland drainage and so on and so forth. So this kind of information is put forward to work with countries, support countries, help them think about the makeup of their food systems in a detailed way. And of course, because we have a database that speaks to other domains in FAUST, you can then relate information also, for example, to look at emissions per capita, which is another important indicator that many countries, of course, want to consider in their policy action, in developing their policy actions. So I conclude with that, just with two simple thoughts. I mean, of course, food systems, food and agriculture are responsible for a large share of emissions. I didn't mention it in this presentation. Of course, Walter mentioned it. Of course, agriculture is a big one of the sectors that will be hit hard and negatively by climate change. So both aspects make food systems a critical component of climate actions that should be considered by countries. And the other point to bring home from the presentation is that granular and more detailed data, detail over time and at country level, the makeup of food systems is helpful because it helps highlight hotspots of emissions for intervention, including within a better characterization towards food systems in national determined contributions. So with that, I thank you for your attention, and over to you, David.
Thank you, Francesco. That was fascinating. And there's so many observations and insights that you offered there, and lots of follow-up. We'll get into more in the Q&A. One thing I noticed is that the emissions from 1990 today in the food systems seem to have gone up much less than global emissions overall. I think global emissions overall, if I'm remembering, I mean, they've gone up by about 40% maybe since 1990, something like that, maybe even a little bit more. And food system emissions, I think you said, have gone up from 15.5 to 18 gigatons. It's kind of, so it's interesting. And do you think, is that mainly driven by a slowdown in deforestation or any idea, something different?
Yeah, I mean, yes. Absolutely, the large share that describes those they're remaining almost stable. In fact, if you look at that graph, it's basically the fact that deforestation today is basically a third. Although I want to stress it's still an important problem that needs to be addressed until it goes to zero. But it's about a third of what it was in circa the year 2000, and that has affected greatly the food system trends.
Oh, very interesting. Well, we'll come back to this. And now for our final presentation, delighted to welcome back Cynthia Rosenzweig of Columbia University and NASA Goddard and the Food Climate Partnership. Welcome, Cynthia.
Thank you very much. I'm working on getting my, let me get to the beginning. Here we go. Yes, I'm happy to carry on with the theme that the other two speakers, I think, have really brought forward so well, of the interplay between science and policy. And I'm going to be sharing some of the activities of AgMIP, which is the Agricultural Model Intercomparison and Improvement Project. It's a network of over 1,000 food modelers all around the world. And so welcome to, I can see in the chat that some of our AgMIP colleagues are participating in this event. So shout out to the members of the network, but to everyone as well. So we call this, in a paper that we just wrote in Environmental Research Letters, the double helix of science and policy. That the work in the science, such as Francesco was just presenting, needs to be and is now much more closely linked with the policy, so that we can make progress on these serious world challenges, as Walter brought up. So I want to start first with just some guiding principles. And these are from the IPCC Special Report on Climate Change and Land, a special report which was part of the sixth assessment cycle that was published. It was published in 2019. So, it's always good. This is, I learned from being a NASA scientist, what is the mission? So these principles are really the mission. The first is about sustainable land and climate management, stewardship and use of land resources, including soils, water, animals, and plants, to meet changing human needs, while simultaneously ensuring the long-term productive potential of these resources and the maintenance of their environmental functions, including, for example, the reduction in greenhouse gas emissions. So that's on the principles for managing our land and climate resources and its relation to climate. But at the same time, we have to be holding the principle of food security in all of the action and activities and responses as well. And here, food security is defined as the situation, and this is from the FAO, situation that exists when all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. And the interpretation of this food security definition now with the phrase "at all times," that not only means within a given year, so that there's no longer or a set of years of feast and famine, but also long-term food security as well, related to, for example, to the changing climate. So here's a little bit more about some of these, fleshing out some of the ways and actions that the science side of the food system and climate change double helix can contribute. So in the IPCC Special Report on Climate Change and Land, in Chapter 6, the author team did a massive review of management options for sustainable land management. Remember, that was one of our first guiding principles. And then they evaluated them for each one of them. You can see them on the left, in agriculture and soils. How well do they help with mitigation of greenhouse gases? How well do they help with adaptation of the food production system to, as Francesco was just reminding us, the impacts of a changing climate? And then at the same time, food security. So they evaluated all the ones on the left, including improving grazing land management, reduce soil erosion, etc. And these are the ones, if you look for the ones, the color blue had the strongest effects, positive effects. And so I've put green stars by the three that help on all three the most. This is a little bit like what Francesco was doing also, is saying we need to help and learn how to prioritize now as we're going forward. There's so many things that can be done, but how do we help? And this is, as scientists from the science side, how do we help the policymakers prioritize? So the ones that seem to be the best on all those guiding principles are increased food productivity. That helps on the mitigation side because of increased carbon sequestration, agroforestry as well, storing of carbon in the forestry stocks, and increased soil organic carbon. of which there's there's a lot of attention on the soil organic carbon now, so that I've chosen that to just give a little bit more information on. And certainly in the United States, this is one of the policy options that is being considered as a response to the greenhouse gas emissions from food. So how do you actually increase soil organic carbon, right? People say, well, yeah, okay, well, how are you going to do it? So you may have heard cover crops, and I think actually President Biden also included cover crops in one of his speeches in the past year. In cover crops, perennial crops, using rotations with legumes, reducing tillage, that is aerating the soil and helping to release the carbon dioxide there, increasing organic matter input into the soil. And then at the same time, reducing soil erosion. If you're keeping your soil right on your fields, the carbon that is in those particles of soil aren't being lost but through erosion or by salinization, the soils becoming salty or becoming compacted. So what does this all lead to? It leads to one thing, many things, but increased water holding capacity, and therefore increased the potential for increased productivity, and therefore resilience during droughts and floods. Both when you have a better sponge, you can hold more water even in dry times, as well as in heavy downpours, which are occurring as well. So this is really why the soil carbon sequestration part is a topic of very, very large discussion and debate. Of course, it depends very much on what soils, where you are, what are the management systems. There's a lot of huge amounts of heterogeneity. But because this can link to both climate and food security through carbon sequestration, availability and reliability of food, this is one of the main response actions that's being discussed. So this is from our colleague Bruno Basso at University of Michigan, or Michigan State, sorry. With a set of 5 models in AgMIP, we always use multiple models to get a better handle on the uncertainties. But this is looking at changes from conventional tillage which stirs up the soil and releases carbon and carbon dioxide, to a no-tillage system, which can increase the organic content of carbon in the soil, as well as the cover crops, which we were mentioning before. Those crops which are planted, let's say in the winter, when the farmers don't have one of their perhaps one of their cash crops in, and that also helps to not leave the bare soil and to build root structure that could be, and biomass that can be plowed in, for example, or held there. Anyway, you can see this is showing % change in slow organic carbon over the period, and it is definitely showing that there is the potential for increases in carbon in the soil in our Midwestern states from these practices. Let's turn to the policy side now, and here I'm sharing policy interventions. Again, like Walter, I'm an agronomist by training, and Walter, I think, is originally a soil scientist. But from working with the other authors of the IPCC special report and the Food Climate Partnership policy experts, these are some of the actual ways that these actions can be nurtured and brought forward on the policy side. So, for example, increased food productivity. Okay, how do we get that as a society? investments in agricultural research and extension and technology transfer. That's when the innovations occur, then they can be they can be disseminated widely. What about agroforestry? These are the ones that have according to the IPCC authors, have the greatest traction. National, here some potential policies and incentives are national level agroforestry plans, having a plan for the whole country. That's a little bit similar to echoing what Francesco was saying, in helping countries to make their own plans for what works best for their food systems. Targeted, another one is targeted microfinance for farmers who want to start have an agroforestry component in their farming system, for example. And then what about the increase in soil organic carbon? Huge amount of debate in the United States and elsewhere about this. Here, some of them are, for some of the actual policy mechanisms are farmer incentives for sustainable practices for cover crops, let's say, and then carbon credit programs. So these are elements that we can see that the technical side and the policy side need to work together to create effective policies. Now, what also I learned from working with the IPCC specialists and from our food climate partnership policy experts is that you need not just the policies and incentives, but you need enabling environments. So even besides those specific policies, you need to have a lot of an environment of large, almost kind of larger, deeper kind of scales, besides the specific granular policies, to actually make these kinds of policies a success. So here, these are things like secure land tenure. In some countries in the world, that is perhaps not very strong. Rights-based decision-making, empowering women. All these things can be creating the environment for action on sustainable land management, climate change, and food security to work. Sustainability standards and certification programs. There's a movement now to do that. Creation and regulation of markets. Let's say it's carbon credit markets. Let's say it's for markets for legumes that are doing that are helping in creating a more sustainable land management. Markets are a key part of farming system. It's a livelihood, as well as all the other functions that it serves. Public-private partnerships. And finally, this one is a very good one, I think, and very important from the research side and the scientist side, metrics for measuring progress towards goals. How are we doing on soil carbon sequestration? How are we doing on our greenhouse gas emissions? That's what a lot of what the Food Climate Partnership is about. So, going to give a brief example of the double helix in action, and want to call out again a program of the Biden administration called AIM-4C, Agricultural Innovation Mission for Climate. And a joint initiative by the US and United Arab Emirates. And it seeks to address the climate crisis by uniting participants to significantly increase and accelerate investment in these kinds of actions that I've just been describing. So its goal is to empower agriculture to be part of the solution. We know from Francesco's presentation and the work of the Food Climate Partnership and other colleagues that the agriculture is a very, very large contributor to climate change. But we need to empower agriculture to be part of the solution, to address the climate crisis, build resilience to its impacts, and create co-benefits of climate action. So just want to very briefly at the end, give a shout out to a new AgMIP project. It's called AgMIP Farming System Mitigation and Adaptation Co-Benefits, that the acronym is MACB. And with funding from Australia, the ACIAR development agency there, there's a new project with Bangladeshi colleagues in Bangladesh. And what this is showing is, I think, as an example of what Walter was saying, how we have to work together in a really transdisciplinary way. First of all, with not only the researchers, but with the decision makers. So that's the stakeholder engagement part. With them, we look at what are pathways to a sustainable agricultural future in all the countries of the world. What are the climate scenarios? That's the science part. The climate is changing. Still, of course, uncertainty about what's going to happen with the UNFCCC. But then really utilize both. We use both the emissions and mitigation models and the impacts and adaptation models. These two things have been siloed tremendously in the work on climate change and agriculture. And to really see how the biophysical and the socioeconomic processes really interact to create synergies, trade-offs, and co-benefits among those actions. And thereby the overarching goal is to contribute to effective policies and programs, bringing the double helix the full circle around its trajectory. A big part of this is capacity building for everybody, all the countries of the world, to have information products of value to stakeholders, and learning from each other. I think the Act Today program is doing that. The AgMIP programs do that. In Bangladesh, our colleagues from CIMMYT, from the Agricultural Research Institute, Rice Research Institute, the Met Department, the Rural Development Academy, all of these are the institutions and organizations that the colleagues on the project are coming from. So it's this kind of work going forward that's going to, I think, help to actually bring the double helix of science and policy to fruition for the major climate action that is needed at this time. So thank you very much. Here's the protocols, up-to-date events and news. Here's the, and to join AgMIP, visit the AgMIP website, www.agmip.org. Thank you very much.
Thank you so much, Cynthia. That was so fascinating. There's so much to follow up on. Boy, one topic you were talking about, which is really, it's important and it's live in the United States today, is around soil carbon. And maybe just to follow up on that, and one dialogue is around the measurement of soil carbon and kind of how good is the measurement, how well can it be quantified, can this be done effectively as part of carbon credit programs? Do you have any thoughts on that? And I know, Walter, this is specialty of yours.
Absolutely. So this is something that the AgMIP US Consortium, with the leadership from Bruno Basso, and I showed his work. So basically, with a combination of field measurements of soil carbon, remote sensing of the landscape, and modeling, there is now very much the potential to get a much better handle on the actual measurements. It's not, you see, in a way, the term measurement is a little misleading because it's like somebody is going around like doing soil samples. Yeah, unfortunately, that will never work because we have to scale up. But by using a multi-model approach, with the measurements, remote sensing, and a multi-model approach of soil carbon and crop models, because you have to have what the crops are doing as well, we can get much better estimates of what the actual soil carbon potential is, and what cover crops, as I showed, it was the no-till, conventional crops versus no-till, and cover crops. So we believe at AgMIP that it will take concerted effort to organize that, and that's what we're really working on doing, is to have a multi-model approach and this is for the US, but also could be worldwide, but to then really establish those baselines with much more rigor than has been done previously.
Walter, do you have thoughts on this?
Yeah, and just to, I mean, I completely agree. The only way to do this is to have very good field measurements and very well calibrated and tested simulation models that you can trust. And for that, one of the things that is very important is around the world, there are several very long-term experiments that are still going on today. And I was just very fortunate to work in one in Uruguay that is more than 60 years old, and they have been measuring carbon year after year. So those long-term experiments are amazingly valuable to calibrate these models that then we can use to estimate changes in carbon. And the other very short comment is that measuring total organic carbon is very difficult. It's not very sensitive. It takes a long time to see the changes. But there's some indicators, carbon fractions that are more sensitive to agricultural practices. And so a combination of what Cynthia said, the field measurements, good crop models, take advantage of the long-term experiments and some of these carbon fractions that are sensitive to agricultural practices.
We have a question in the Q&A from Nataraja Subhash that's relevant to this. I just, or it's a comment to see if people think about it. It's payment of ecosystem services at the farm level will be one of the solutions. However, need to develop methodology for assessment of ecosystem services at the farm level at present, and also with climate change. Do you think we have the underlying scientific assessment tools to pay, to design policies to pay at the farm level for ecosystem services?
I think we do. I think it's really interesting for me what is happening in the industry, in non-agriculture industry, how companies are developing these corporate responsibility units and how they measure these ESG indicators, environment, social, and governance. I think that we can learn a lot from that and start applying the same approach for agriculture production systems. And so create these indicators. How is this production system doing in the environmental aspects? How is it doing in the social aspects? How is it doing in the government aspects? I really think that this is a wonderful concrete opportunity to connect good science with policy. But I think that the model of what the private sector is doing is really interesting, and we should learn from that.
Can I pile on a bit? This is coming from the the network for healthy and sustainable food systems of the Columbia Climate School, of the new climate school. One of our colleagues, Jeff Potent, is working with Hudson Valley farmers. This is also, one of my aphorisms is sustainability begins at home. And right in our own Hudson Valley, there are pilot carbon payment for ecosystem services, including our watershed is a payment. Our payments to our farmers in our watershed is payment for ecosystem services to ensure the safe drinking supply and quality for New York City. But this is now being extended to carbon. And I think that's what we need. We need a lot of pilot projects to learn what works, what doesn't work, to really see how we can really pay our farmers for that sustainable land management, really on which we all depend.
Okay, we have one or two comments that I just want to bring out, and then I want to turn to another topic. I want to talk about diet, but we have a comment from Samanpreet Kaur, I hope I'm saying your name right, from Punjab, who says, we've been using DSSAT for field scale modeling and then integrated inputs in GIS for field scale. Can DSSAT be applied to regional scale?
Very quick, yes, very quick. The answer absolutely is yes. We now have gridded DSSAT We have gridded DISAT and can do it at the national scale. And we also have PDISAT at the global scale. So please follow up with agmip.org and we will hook you up. We have AgMIP has just absolutely fantastic colleagues in Pakistan and definitely want to hook you all up together.
Wonderful. Francesco, please.
Yes. So I just wanted to add just one brief thought on this. So certainly, I think innovation is, so we're talking about science and policy, but here I think there is an innovation dimension, which is not exactly science research, right? It's the implementation component, and that has made fantastic strides over the last years, because we've heard from Cynthia talking about models and remote sensing, of course, a lot of machine learning progress, will go into this machinery of monitoring soil carbon. And I think, that will be done. The machinery is maturing for action. The policy, I think, needs still some guidance from the kind of 360 degrees information of, the type of databases that I showed, but not necessarily that only as a tool to, it will depend country by country whether it would make sense to do it vis-a-vis other things that you can do in your food system supply. So the United States for sure is a place where this will make a big impact, but others need to be analyzed. And just a note from an FAO perspective in working with countries, most of our member countries are developing countries. Once this machinery, gets put in place, there is an issue on equity or who are the big companies that drive this machinery, and is it fair? So there's a lot of research that needs to be done on how, to ensure that the innovation is then possible, can be transferred in fair manners to countries that don't have so much money or technology to implement. Over to you.
Thank you. I'd like to turn to a topic that hasn't been discussed much so far, which is diet and the role of animal agriculture in particular in this whole issue. And it's one of the most sensitive issues in this whole area. It raises both equity issues and deep cultural issues. But I wonder if anyone has any comments first on the role of animal agriculture in climate change. I've seen statistics that 15% of greenhouse gas emissions are from livestock. Is that accurate? And then if it is, then what are appropriate measures that can be taken to begin to address this?
So if I may, I think that that's a very important question. And a typical way to ask the question is what you just did, David. It's animal production bad for climate change? And that's similar to asking, are cars bad to climate change? So my reaction would be, what car are you talking about? Are you talking about a car that has a huge engine and is generating a lot of greenhouse gases? Are you talking a hybrid that gives 30 kilometers per liter? Or you're talking about an electric car, which is not emitting at all? With animal production is the same. What is the animal production system they are talking about? If you're talking about a production that goes into a tropical forest, releases a lot of carbon that was trapped in the forest and in the soil, releases that carbon to the atmosphere, then goes and plants a pasture, and then goes and raises ruminants, then that's terrible. It's terrible mainly because you're releasing huge amounts of carbon that were not in the atmosphere before. But if you are working in a place where natural grassland, where for millions of years, they had large herbivores, they had ruminants, having the ruminants are part of the reason why the natural ecosystem is preserved, because if you take the animals, then the natural pastures get degraded. In those cases, that's also animal production, but the carbon dynamics, the ecosystem services, the biodiversity situation is completely different. So I think I really hope that we bring maturity to this discussion. There's not one animal production. And so saying animal production is good or bad doesn't help. It's like saying, let's look at case by case. There's some cases where the animal production may be totally fine. And in some cases, the animal production system is completely wrong. And then the other thing that we usually forget about when we discuss these things is how many million people, small farmers, depend on these livestock production systems. Some of them in these natural grasslands. And so I think it's very important to discuss it. I think it's important to have a broad range when we discuss it. Thank you.
Thank you. Other thoughts, Francesco or Cynthia?
Yeah, I'll gladly add some. So certainly, I agree with the positions that Walter has put forward. I think the fact remains, the numbers are numbers, right? So if you look at emissions from within the farm gate, so we're talking only about non-CO2 emissions, I mean, 3/4 of those. See, so I agree with the characterization. We tend to say 3/4 of those come from livestock, but the reality, it comes from dairy fermentation, largely in intensive cattle production, right? So we're not talking about goats, pigs, or other animals. Of course, large numbers, which is what we're dealing with, right? At the end of the problem, at the end of the analysis, is what causes the entire problem. So of course, there is an issue with natural, nitrogen, carbon cycle, and the role that herbivores played, which is, I think, obviously needs to be recognized and somehow built into the methodologies. But there is no doubt that the acceleration of numbers, first of all, us, right? We went from 2 billion to 8 billion in one century, and we carried with us all those animals. I mean, in terms of, not figuratively speaking, in terms of having, billions of more animals serving our food system is a problem. Now, I think, I think, at least from my perspective, I come from a climate change perspective. I'm a climate change scientist. So as long as we talk about emissions and climate change, I think the ultimate problem is, we need to do something so that the atmosphere sees a signal, right? And we need to do it fast, right? Planet is burning. We've tried with the UNFCCC for 30 years. We need to sort of put that system on steroids, as we all know, right? And so if we only talk about climate and reducing that signal, any other consideration, social, cultural, is important, but needs to be put in a separate discussion place, right? What we have, the big challenge that we have for the next 10 years is actually send a signal to the atmosphere that we're serious. The other thing that's important here, and I think that links this issue to supply and demand. So this is a space where both actors, in fact, throughout food systems, there is a duty for food producers to improve their practices to do less harm, let's say, or to reduce the carbon footprint of their products. And there is a huge role in consumers in making, choices of diets, including plant food diets that are, scaled up and have some effects at regime. The main issue is how long is it going to take?
Can I have a very short comment? I was thinking what Francesco just said is very important. We have very little time, right? And we need to send signals that are sensitive in the atmosphere. And I was very happy to see the last IPCC report, which is coming up now. And basically what it's saying is we should concentrate in methane. Methane has a life cycle of about 10 to 15 years compared to CO2 has 1,000 years. And so we should do something about it. But then in the people's mind, because we have been having this discussion, I think, in a too simplified way, that means kill the animals, get rid of the ruminant. And the reality is that just by reducing 20%, the losses, the emissions of methane from the fossil fuel combustion, that will bring methane to zero balance. If we can reduce it by 30%, then, and that is, to be honest, that's being very pragmatic. in 10 years, I think that that's probably a lot more achievable than trying to change the whole world's diet. So, let's be pragmatic. And there's a lot of things that we can do. And the other thing, the other big concept is the carbon, the big problem that we have with climate change is that up to the Industrial Revolution, we have a very nice carbon cycle working very nice in equilibrium. Then we started for 300 years, we started taking carbon that was not in the system and injecting it. And so that's the key. What happens with the recycling processes is completely different than what happens with adding the new carbon from fossil fuels. So we should not distract our attention from that. That's what is really hurtful for the planet, is the new carbon that we have been injecting to the cycle for 300 years.
Thank you. We have a number of questions on developing country issues, and in one very general one, which is, I think, really important, from Frazia Matfumo, to assist developing countries to implement climate change policies. Anybody like to speak broadly to that?
I feel like I'm talking too much, but I can give it a try. I think that, this is part of what brought us together today, right? Is developing countries have to ensure food security, have to ensure a sustainable growth, sustainable development. And we are also asking that that is done in a, responsible way. Now, there's some things that some developing countries are doing, and I believe they're great. One example is this idea of the sustainable bonds, right? So, developing countries have to get debt. They have to get loans for all the development programs. And what happens today is that if your economy as a developing country is not very stable, you have to pay very high rates of interest for the money that you loan. Now, what some countries are proposing now is to issue sustainable bonds, which means the interest rate that I pay will be higher if I do something wrong in ESG. So if I'm doing something that is not sustainable, that money I have to pay back with high interest rates. But if I do a good job, if I implement sustainable development practices, then the interest rate that I pay on that loan is very low. And that is a very practical way to promote sustainable practices. So that's one idea. Now, the nice thing of that is that how do you measure sustainability? Again, you need a good connection, strong connection to the science community that measures those indicators in a very robust way. That's an example.
Great. And Francesco, and it's for everyone, we're supposed to end at 1:30. We're going to run this just a few minutes past that because we have some really interesting comments we want to bring in, and but we'll close soon after the halfway past the hour, which is in about 5 minutes. Francesco.
Yeah, so very briefly, of course, FAO is heavily involved from many angles of the institution in supporting member countries, help understand, possible areas of actions, and in fact implementing actions on the ground, FAO together with many of the international agencies. One area that I think it's worth highlighting, within the information that we shared in the panel, and of course we're talking about food systems, is developing countries, especially poor developing countries, are sort of in this global ambition game, are in a big bind now because of the state of their economies. The share of their total emissions in terms of food system share, and in fact farm and land use change, is very high, right? So obviously they have to choose very wisely where to act. The issue is also, does it make sense? So databases like the one that we presented can put things in perspective. I mean, you have a high share of emissions from agriculture, but in absolute amounts it's very small. So perhaps you shouldn't, do that at all costs, let's say. But the type of analysis that we've done points, like I was saying, to how the different makeups of food systems around the world, and certainly in not emerging economies, but in many poor developing countries, the main issue is actually CO2 from ecosystems destruction. Where I would highlight, and that of course links to things like trade and our responsibilities, because a lot of the food we consume, or increasingly less, fortunately, but some of it still comes from those kind of processes. So there is the double, the dialogue that needs to be implemented. So it's action within a country to save ecosystems within the territory, but also actions internationally to make sure that food that is exported doesn't pass through that negative storyline. Yeah, over.
Great. Well, as I said, we're almost out of time. I want to bring in one comment we've received from Matthew Hayek of NYU, who's a co-founder of the Food Climate Partnership, and then close talking about the climate school at Columbia. Matthew writes the following, just to see whether anyone has any thoughts on it. This could be the topic of an entire separate session, and maybe we should do that. But Matthew writes, isn't that distinction increasingly less relevant between where we're producing ruminants like cattle, when beef is an increasingly globalized commodity? We're grazing cattle in every major native grassland biome globally, yet still deforesting tropical forests to produce even more for rising regional and global demand for beef. Seems like demand is outstripping the carrying capacity. And I guess I'd read that in case anyone has any thoughts or comments on that, and wonder whether shifting diets is part of the approach here that we should be thinking about in light of this.
Very shortly, of course, I completely agree. But again, the problem is, I think, the way that I see it, the problem is not the systems that are based on natural grasslands where they always have ruminants and where you need the ruminants to preserve the biodiversity. The big problem is where they are, land use changes, but that deforestation, where they're using, changing land uses in a way that destroys biodiversity, increases positive carbon emissions. So yes, I think that changes in diet I think it's a very good way to move it. What I was trying to say is that sometimes I worry that we get very interesting discussions in these areas, and we sort of get our attention away from the big problem, which is fossil fuels. And so what I'm saying is that everything helps. Of course, everything helps. But my very general message is everything helps. Let's not forget what is the main problem. And two, let's not talk about animal production system as something homogeneous, because it's not. And that's mainly it.
Great, thank you. Well, in our overtime here, I just want to close talking about the Columbia Climate School and interdisciplinary research in general. And someone has written specifically to Walter, said the interdisciplinary Columbia Climate School is excellent and first, kudos. Could you comment on how basic research such as breeding better crop varieties could be done under this framework? Maybe Walter, go to you, and then Francesco, I know, and then Cynthia can close us out, but for any thoughts on related topics. So Walter.
Yeah, so I am so happy that we had that question, because I was worried that the message that was interpreted that I think that everybody should go apply research and forget about basic research. No, I mean, if we don't have the strong, basic, very specialized research, we don't progress. We need that. We need genetic engineering. We need basic research in physics, in mathematics, in epidemiology. We need that. Otherwise, our science, our knowledge doesn't progress. What I think is that what is missing, but that we have that. In a place like Columbia, we have some of the best scientists in the world in many different areas. What we don't have enough is people that can take that very specialized knowledge and integrate it in a way that becomes useful for policy, useful for decisions. So if we don't keep stimulating, promoting very good basic research, that's suicidal. But what we need to do is add this new figure, the integrator. That's what we don't have enough.
Well, thank you, Walter, and thank you for all your work and leadership on this. And Francesco, do you have any thoughts on that or related topics? Any last words?
Yeah, maybe a few concluding thoughts, but maybe to highlight something that I haven't touched upon, or we haven't touched upon yet. So I don't want to go out of so just very briefly, I mean, to me, the kind of actions, just to repeat what I said before, I mean, we're on a call to action that needs to be immediate. If you look at food systems, to me, main action is on reducing that land use change and ecosystem destruction. Still emits a lot of CO2. Granted, CO2 is one of the important, perhaps the most important gas we need to deal with. Since now we're highlighting there's a lot of fossil fuel use on the farm, shift to renewables on farm production is another strategy we should increasingly be talking about. And I think within the farm, I mean, you don't get away from trying to make more sustainable, currently unsustainable intensive system wherever they are, which also includes, by default, the sheer numbers livestock, but intensive ruminants without generalizing, like Walter says. Just to highlight, the land sector, this is another policy jargon, because to me, there is no such thing as a land sector except in a greenhouse gas inventory or in an NDC, is what everybody is hoping to use to arrive to the concept of net zero, right? So, we talk about getting to zero, we don't talk about getting to zero emissions by 2050 and beyond, but net zero. And the only way you get there is basically by foresting or by managing the land component. And so there is a lot of temptations, right? Both in the past carbon markets that I think so far failed, and in the future to sort of, develop projects to sequester carbon, to generate offsets, to then give it to somebody that keeps on emitting, sort of almost business as usual. Now, to me, that's to be avoided like the plague. As I said, we have about 10 to 20 years. So the actions need to be done in both areas. Yes, sequester carbon on land wherever it can, including soil carbon sequestration on farms and avoiding destruction of ecosystems, but don't generate credits and offsets to let other people get off the hook, because we're not going to save the planet that way.
Great, thank you. Cynthia, you have the last word.
Great, thank you. I want to bring up, I think, something that that's germane actually to certainly the discussion of diets, the very challenging, always discussion of the role of the role of the livestock production in all its different forms, but it's the links to human health and nutrition, and that's something that has been, for me personally, really great about the formation, the evolving climate school, because the network that Walter and I are part of has brought in the Columbia Medical School and the doctors who deal with, for example, obesity in children in New York City. So it makes it very, very real, I think, and that I think as we go forward to solve it comes back to my point about we have to be solving food security in all of its aspects, as well as the planetary health as well. And I think that healthy part is a key way that we can bring in the diets, I think, in a because unhealthy diets lead to terrible, are causing a lot of the very, very important health problems, and very expensive for governments. So again, taking this, I think, integrated and holistic approach not in any kind of simplistic way, but bringing in multiple co-benefits so that we can then address climate change as well as human health. So I think that's an example of how efforts like the Food Climate Partnership, like the network, the Food Network in the Climate School, that this is the kind of integrated work that we all need to work on together to solve these grand challenges.
Well, thank you, Cynthia. Big thanks to our brilliant speakers for their great comments and thoughts. I want to thank Eric Mankos, who just did a tremendous job pulling this whole session together. We really appreciate his work behind the scenes. Terry Nip as well, and Kevin Carl, who also really did a tremendous job helping pull this event together. And to all of you who've been listening and participating, we're sorry we weren't able to get to everybody's question. We could have kept on going, but we're actually over time. Please visit the foodclimatepartnership.org website and as well as the Columbia Climate School, a very exciting initiative bringing together interdisciplinary work on all of these issues. Thanks, everybody, and have a great day.